Hey champions! Today we are diving into algorithms. Basically, how to make your brain talk to a computer without screaming. Welcome, aspirants. Today we are beginning our WBCS computer science journey, and what better way to start with algorithms and problem solving? The first and most important topic for paper 1. In WBCS optional, this topic is just the first. From defining an algorithm to flowcharts and pseudocode, and even analyzing efficiency, we'll cover the full picture in under 10 minutes. So, optional fun poll on screen. What is an algorithm? A spicy food item in South India or Mark Zuckerberg's bedtime story? Why do most toppers master this topic early? Because it shows up every single year in the exam. Let's put it this way. If you have ever made Maggie without burning the kitchen, you have used an algorithm. Computers need their instructions, but they are not your mom. They won't guess what you meant. Be clear or get errors. So, what is an algorithm? Which is a fundamental question. An algorithm is not code, it's a structured approach, like a recipe. Let's make this a fun example. Making tea. Just like this, an algorithm for a computer must be precise, finite, and must give the fun right analogy. Making tea is algorithm. Asking your sibling to make tea is equal to machine learning. Getting tea without asking is equal to AI. An algorithm consists of input, finiteness, correctness, and output. Flowcharts are like memes, visual, shareable, and sometimes oversimplified. Pseudocode is like English. I mean, English. Half programming. It's not real code, but it gets the job done. Use caps to look serious, like you're yelling at the code. Read A, B. Selection is decision making, or what I go through every evening. Should I study or scroll Instagram? So, this is how we represent algorithms. The oval is primarily for start. We have the parallelogram, which is to represent a process. Then we have the diamond, which is for decision making. A rectangle is basically again for process, and that is how we represent the complete algorithm. Let me just draw the arrows real quickly. So to find max of two numbers, A and B, how would you do it? So we want to find the max of two numbers, A and B. This right here is what we call as a visual algorithm. Very useful for exam answers, especially for descriptive questions. This is what we call as pseudocode. Structured English that represents code, but isn't language specific. Loop doing something again and again until a condition breaks. Remember to always use proper indentation, meaningful variable names, and standard keywords like if, while, etc. Kind of like me trying to wake up at 6 a.m. and falling 5 times in a row. So, for the next topic is control structures. It's basically sequences. So, sequences is one type of control structure where you have a simple linear execution like so. For loop is equal to I know how many times. Like our T example. While loop is let's find out. Repeat until is equal to at least try once, like every New Year resolution, which never happens. The next topic inside of control structures is called selection. So tell me, what will this print if temperature is equal to 32? Next we have iteration, which is another control structure where you're basically looping. Looping is essential, especially when we don't know how many times we'll repeat something. This is how you check if a number is prime and how you check if a person is prime for WBCS. Divide them with pressure. If they break, not prime. Coming to big O examples. O of 1 could be like snack from your pocket. O of log n could be half the problem like you half your pizza. O of n, check each item. Boring. O of n square, nested loops like friendship drama. Everyone talks to everyone. Remember, practice makes perfect. Pause now and try these. I'll wait. Or maybe I'll go get tea. Either way, do this. WBACS won't wait. Don't worry if you mess up. In programming, errors are just confused instructions asking for love. Today, you officially started your CS prep the right way by learning to think like a machine, but in a human way. Next time, number systems, where 10 is equal to 1010 and nothing makes sense until it does. Algorithm analysis is like measuring your code's efficiency or how fast you can eat a pizza. That's it for today's algorithm adventure. You survived, and you might even have learned something. Flowcharts are like maps for your code, or like a choose your own adventure book. Except instead of choosing your own adventure, you're choosing your own errors. So, this is a classic WBCS level question. You may be asked to write this as pseudocode or draw its flowchart. Selection is like making a decision. Should I eat pizza or salad? Should I learn algorithms or watch Netflix? Iteration is like repeating a task until you're tired, or until you have watched all the cat videos on YouTube. Let's check if a number is prime or if your code is prime time ready. Spoiler alert, it's probably not. Algorithm analysis is like measuring your code's efficiency or how fast you can eat a pizza. Except instead of pizza, it's code, and instead of eating, it's running. Now it's your turn. Write pseudocode to solve these problems, and don't worry if you mess up. After all, that's what debugging is for, or your therapist. Sequence is like following a recipe, step by step. Like making Maggie noodles or your bedtime routine? Mini challenge. Write a sequence of steps to make your favorite snack. Let's check if a number is prime or if your code is prime time ready. So, what is an algorithm? It's like a recipe for your favorite dish. But instead of ingredients, you don't have code. And just like your mom's recipe, it's all about the steps. So we evaluate algorithms using big O notation to measure efficiency. You may ask what an algorithm is. Well, it's sort of like saying it doesn't involve binary yet. So cherish this moment before you start crying out binary. So O of 1 is constant time. O of log n is logarithmic. O of n is linear. And O of n square is quadratic. You don't have to memorize, but understand the idea faster is better. In the algorithm example, check prime, what we do is we first read n, then set is prime is equal to true. Then if n is less than equal to 1, what we do is we set is prime is equal to false, and so on. You can take a look at this example later. Now let's take a look at a very fun and interesting mini assignment. For this assignment, there are going to be 2 to 3 steps which you will need to follow. I'll just make this clear and write it down so that you get a better idea of what's coming ahead. So pause here and try these. These are real WBCS type questions, great for both theory and practice. So write pseudocode to find the largest of 3 numbers. Second is to calculate the sum of the first n numbers. And third is to generate the first n Fibonacci numbers. We'll take a look at this later. For now, let's just summarize what we have understood and studied till now. Hey champions, our course is going to end. I'm sorry, the lecture. Today, we learn how to make your brain talk to a computer without screaming. That is what we learned. In WBCS optional, this topic is not just the first, it's the most likable one. Why? Again, coming back, it doesn't involve binary yet. So cherish this moment before you start crying about binary. So what is an algorithm? Again, repeating. It's like a recipe for your favorite dish, but instead of ingredients, you have code. It's fast, it's efficient, it's step by step, and it's complex. Flowcharts are like maps for your code, or like a choose your own adventure book. Except instead of choosing your own adventure, you choose your own errors. Design a flowchart. Can you design a simple flowchart for a real life problem? In the next lecture, we'll tackle number lessons. In the next lecture, we'll tackle number systems, binary, octal, and more. Another favorite topic in paper 1.